For the rest of the discussion. Thanks. Next, I'm going to introduce Robin. So Robin is from Earth Daily Analytics. It's headquartered in Canada. And Earth Daily are a data and analytics company. Robin's role there is developing their machine learning analytics, training capabilities, outreach. Robin's a well-known authority in machine and deep learning techniques for processing remote sense data. I've written here, Earth Observation Evangelist. I'm not sure if that was something that I picked up, but certainly from reading all of the great stuff you've done, I think reads really true, and is founder of satelliteimagedeeplearning.com, so an online resource for people who are trying to make better use of their technologies too. Robin, really looking forward to hearing what you need to tell us about. Thank you.
Okay, so I'll just tell you a little bit more about myself, I guess. So I've got a physics background, like many people in the room, but I now work on machine learning, primarily focusing on deep learning techniques. As mentioned, I work for Earth Daily Analytics. This is a Canadian company. We've been around for, I think, 4 or 5 years, but the plan is next year we're launching a constellation of 10 Earth imaging satellites. These are going to be very high quality data streams. It's spectrally matched to Sentinel-2, but we're going to have 22 channels covering all the way from RGB out to thermal bands, and medium high resolution as well, so 5 meter pixels. Okay, so today I'm going to talk about the potential of AI and Earth observation for a sustainable and resilient future. So what I'm going to do is just focus on 4 key applications and give examples in each how AI is unlocking the power of the EO data. First of all, I'm going to just talk about disaster prevention and response, move on to precision farming and food security, then environmental and biodiversity monitoring, and finally mapping urban change and context. So the first example is around disaster prevention. I would assume that some people in the room are familiar with this map over here. What it's showing actually is the output of a model that's predicting floods under various circumstances. And what's happened here is that we can use machine learning to combine both models of climate and also high resolution data, topological data, or Earth observation imagery data to predict potential flood prone areas. This will allow targeted investment of infrastructure and prevention systems such as dams, levees, and drainage systems. Second application in this area I'm going to talk about is disaster response, and what I've got here is an example of how machine learning can be used to identify flooded roads and buildings, and also additionally to estimate the fastest route through those flooded areas. This is actually a competition that was run recently, and as I mentioned, it's not just predicting where the flood is, but also behavior in that flood zone about how first responders can get to people trapped in buildings in the flooded area. Moving on to fire. So this is an example of how machine learning can be used to automatically quantify the severity of a wildfire and the damage that's caused. Some imagery on the right over here. This is Sentinel-2 imagery. This is Purbright Ranges in the UK, and this is showing a fire. I'm not sure which year this was, but nevertheless, I think this is a SWIR image, and you can quite clearly see the fire and also the damage that's been caused by the fire. And what people are able to do is to take those kind of images and train machine learning models, which can then quantify or regress the exact amount of damage and fire severity in those images. Moving on to precision farming and food security. So what I've got here is an example of how we can use Earth observation data captured at very high temporal frequency to get insights into the state of crops and their health. What we've got here is just a graphic which shows captured images over time, and you can see the seasonality effects during the summer months. The crops are vivid, and we could generate this kind of time series, and this will allow insights into what's actually happening with the crops. So for example, we can see there's a dip in crop yield here, and maybe a slower growth curve in the crop growth there. And what's required here is both high temporal resolution and high radiometric accuracy, essentially. And by using machine learning, we're able to unlock automatically the insights in this data, and as I mentioned, to get insights into crop health and growth. Is this working? It's gone quiet. Anyway. So precision farming and food security. Thank you. So moving on, still in the theme of precision farming and food security, we can use machine learning to forecast crop yields and identify potential risks to those yields. This will allow farmers to make informed decisions that will enhance our food security situation and also enhance the profitability of those operations. Again, so combining remote sensing data, map data, and performing analytics or processing using neural networks, we're able to develop these kind of visualizations of predicted crop yield. This is from a group at Stanford. Moving on to environmental and biodiversity monitoring, we can use machine learning to evaluate large data sets, and this will give us insights into the health and function of both these environmental and biodiversity systems. This can provide valuable insights for development of sustainable land use practices. And in the images shown here, this is actually from Earth Daily Analytics Agro. This is showing land use or land type classification using a multispectral data and very high resolution data at that. And this is allowing to understand the specific makeup of the land type in this area. And this will be extracted using machine learning approach as well. Moving on to biodiversity monitoring, we can use machine learning to generate insights specific to kinds of populations, animal populations and habitats. And this is going to provide crucial information to inform conservation efforts. This is an example from a recent paper where they're actually trying to understand the impact of the environment on butterfly populations. And they've processed the remote sensing data to identify particular types of land cover and then overlaid the data on the butterfly populations onto that to get a deeper understanding of how those two factors are related to each other. Moving on to the final topic, which is mapping urban change. As one of the other speakers mentioned, we can use machine learning to understand built structures, the urban world. For example, this will produce information automatically, which can be used to inform local authorities about changes in planning compliance or identifying illegal structures. Again, this is a machine learning driven approach where we basically take pairs of images captured at different times. Using annotated data, we can train a model which will then identify specific changes in the urban fabric, here producing a change map showing new buildings identified. This is another application. This is about mapping urban context. So machine learning can be used to process high resolution satellite images and identify different groups of areas inside a city. This example is from a recent paper, and this is actually over Liverpool. And by training a machine learning model to identify features in the imagery and then performing clustering, the researchers were able to identify 7 different kinds of area inside Liverpool, from inner city, residential properties, high density urban, and a few other classes. This will allow us to get a greater understanding of the characteristics of different areas in the city and can inform decision making. Just to give a brief introduction to what we're working on at Earth Daily Analytics, I've got an example of 4 applications that are under development. The first is around monitoring aircraft activity, and this is a defense application. The second application is around monitoring unregistered vessels, indicated there. The next one is around identifying and locating illegal airstrips in the Amazonian rainforest, and the final application is around identifying particular kinds of crop areas. I think that's in France. And thank you very much for listening.
Thank you. Great fly through of all the different applications that we could be thinking about. Next, I'd like to introduce Charlie. So